Hey everyone, Mr. Newman here, and today we're going to learn about systems of equations and how to solve them by graphing. So first off, you need to know that on the graph, the solution is the intersection of the two lines. You get one line from each equation, each linear equation, and the intersection is where they cross. So, for example, on the right here, what is the solution of this graph? Well, the intersection is 2, 3, so that point right there, 2, 3, is the solution. So all we have to do is graph the two lines and name the point where they cross, and we have our solution. Well, great. We just have to remember how to graph our lines, and that's what we're going to practice right here. So first, I teach graphing a little bit differently than a lot of other teachers. The way I do it makes sure that you have the points available, and I think it's the best way to remember. But if you want to have another way to graph and you are confident in that, you may graph it however you wish to graph your lines. So, how do we graph a line? In this class, what I do is I make a table for x and y. So let's do that for this first one right here. Then y equals negative 2x plus 1. X and y table. Great. Next, we're going to plug in values, and I would always recommend starting with plugging in 0 for x. Notice I left some space down there because I might want to plug in some negative numbers above it and some positive numbers below it. So I'm going to plug 0 into our equation, which is right there. Plug it in for x. So I'm going to write this out. Negative 2 times 0 plus 1. Well, negative 2 times 0 plus 1 is 1. So my point is 0, 1. The y value is 1. I'm going to plot that point right there, 0, 1. Notice when I plug in 0 for the x value, that will always be on the y-axis, so we're figuring out our y-intercept every time. Next, I'm going to plug in the number 1. So if I plug in 1 here in for x again, then I get negative 2 times 1 plus 1, which is negative 1. So 1, negative 1 is my next point. After that, I'm going to plug in 2. And notice I'm just plugging in numbers that make sense, that are close to 0, pretty small numbers, so it's easy to plug in, or easier to plug in. And when I plug in 2 there, negative 2 times 2 plus 1 gives me negative 3, and I can plot that point as well. 2, negative 3. Let's also plug in a negative number. So if I plug in negative 1 there, negative 2 times negative 1 is positive 2, plus 1 gives us positive 3. So I can plot that point, negative 1, 3. And I would recommend, if possible, plotting at least 3 points. That way you are sure you have a straight line and didn't do any arithmetic mistakes. This makes a straight line, and some things I want you to notice is each dot I draw is, when you take a step to the right, you go down 2. That is shown by the slope here of negative 2. Also, the y-intercept is 1. That is always going to be that value out there to the side as well. So some people like using slope and y-intercept instead to guide them on their lines, but I prefer making a table of values. So let's connect the dot. You always have to draw a line through all of them because every point that this equation fits is not just integers or whole numbers. It's also fractions and decimals in between. Let's now make a table for the next equation. I first draw x and y, and I'm going to put my 0 down a little bit. Now, when I plug in 0 here, in for the x in the second equation, we get 2 times 0 plus 5, and that is 5. So I can plot that point. Next, I'll try plugging in a 1 here, and when you plug in 1, you get 2 times 1 plus 5, and that is 7. Uh-oh. I cannot graph 7 because 7 is too high. So what I need to do is I need to stop going in the positive direction, and I need to turn around and try some negative numbers. I know that 2 is going to be even higher, 3 is even higher, 4 is even higher, so let's not do any more there. Let's go back to negative 1 and try that. Well, when I plug in negative 1, 2 times negative 1 is negative 2, plus 3 is, oops, that's a typo there. It should be plus 5 is 3. Great, I can plot that point, and we get negative 1, 3. Next, let's plug in negative 2 just to be sure. We plug in negative 2 here. We get 2 times negative 2 is negative 4, plus 3 is 1. So the point negative 2, 1 is right down there, and sure enough, we have a straight line. I'll connect those dots, and the final thing I have to do is figure out what is the solution, what's where the lines intersect, where they cross. That is right there at negative 1, 3. So I'll write that down there in my solution. The other thing I want you to notice is the other nice thing about making a table of values is you can find that the solution, that is the only pair of numbers that shows up together in both tables. No other pair of numbers should show up in your table like that. So -1, 3 is in the red table, and -1, 3 is in the blue table as well. Let's try a few other problems here. So one thing I said was make your table and plug in 0. When you plug in 0 here, I won't always write this out. I'll write it a few more times, but I expect you guys to be able to do that math on your own. 1/2 times 0 is 0, minus 1 gives us -1. So let's plot the point 0, -1. Now before I was doing 0, 1, 2, 3, 4, and -1, -2, and -3. That's if your slope is a whole number or an integer. Here, however, we have a fraction. And what I would recommend is trying to plug in the number in the denominator. So you see the number down there is 2. That number, when you plug in that number next, gives you the next whole number. If you try to plug in 1, you'll get a fraction. And you could plot it, but it gets to be a little messy. So I would recommend plugging in 2 and multiples of 2. So I'm going to try 2 and 4 and -2 and -4, all because of the denominator, that number in the bottom of the fraction of the slope, is 2. So let's plug in 2 and see what happens. You notice 1/2 times 2 is 1. It always becomes an integer if you plug in multiples of the denominator, and that is why I recommend doing that. So we get the point 2, 0. For those of you graphing using rise over run, you notice we just went right 2 and up 1, or up 1 and right 2. That's rise 1, run 2. So 1/2 is up 1, right 2. That's another way to graph that, but I prefer the table. When you plug in 1, like I said, I'm not going to plug in any more values for you guys. You guys know how to do that now. So I'll just plug in the result. We get 1, so 4, 1 is a point. When you plug in -2, you get -2. And when you plug in -4, you get -3. So once we plotted all those points, you notice they make a straight line. We'll connect those dots. And now let's try to graph the other one. When I plug in 0, I get 6. Uh-oh. Well, I can't plot that. Let's try 1 and see what happens. See if we go up or down. When I plug in 1 there, let's see, -3 times 1 is -3 plus 6 is 3. So, phew, we can graph that. And I know I'm going in the right direction, so I should keep increasing my x value. So let's try 2 now. When you plug in a 2, you get 0. When you plug in a 3, you get -3. So I can draw a line across those 3. There, make a straight line. Write 1 down 3 is a slope of -3. And my solution is 2, 0. Notice another advantage of this, of making a table over using your y-intercept and your slope, is that here we don't actually have the y-intercept graphed because it's off above the graph, which is troubling if we weren't just plotting points and connecting the dots, which I prefer. All right. Another thing I want to point out, reminder, the solution is 2, 0. That's the only pair of points that shows up in both tables. That doesn't mean it will show up in both tables. You might not get around to plotting that point, but it's the only one that can show up in both tables if you wrote down all the solutions. Let's do the next one here a little faster. I plug in 0, I get -1. The next number I want to try is not 1, but I want to try plugging in 2 because the denominator, the bottom of the fraction of the slope there, is 2. And so I plug in 2, I get -2. Next, I want to plug in 4. Again, these are multiples of 2. Going up by 2 each time, I get -3. Let's also try -2. We get 0, and we plug in -4, we get 1. Let's plot those 5 points. Notice they make a straight line, and I connect those dots. For the next equation, I'm going to try plugging in 0, and I get -4. However, the next number I want to try, because it's a fraction, is not 1, it's 4. So we plug in 4 and we get -3. I'm also going to plug in -4 and I get -5. Now I could plug in 8, that'd be the next multiple, but that would be off the graph, so I don't need to do that. Notice here, the only pair of numbers that shows up in both tables is 4, -3. So that, I'm guessing, will be my solution. And when I plot the points and connect the dots, it is indeed our solution, 4, -3. One more I want to show you that is a little trickier is this first equation here. When I plug in 0, Well, where do I plug it in? There's no x to plug in. Sometimes this throws people for a loop, and we were asking, well, what's the y value? Well, look at the equation. It tells you what the y value is. Y equals -1. So our y value is -1. If there's nowhere to plug an x in, you don't plug in any x. You just look at what y is equal to. What if I plug in 1? Well, there's nowhere to plug it in, so y is -1. What if I plug in, no, y is -1. And y is -1, and y is -1. So our y value is -1 for all of those. Let's plot those points, and you see what happens. We end up with a horizontal line. Now, some people try to memorize, oh, if it's y equals, it's horizontal. If it's x equals, it's vertical. I say don't try to memorize extra stuff. Just make a table of values and see what happens. And when you look at that, you go, yeah, that's a horizontal line, so we connect the dots. Great. All right, let's try the next table. Notice for 0, I'm going to plug in 4. However, we have a fraction for the slope, so I'm not going to plug in 1 next. I'm going to plug in 2 because that's on the denominator. So plug in 2 and 4 and -2 and -4, and you get 2 is -1, 4 is -6, which is off the graph. -2 is 9, and that's also off the graph, so I know that -4 is going to be off the graph too, so I don't need to actually plot that one. So let's plot the points we can. All we can plot are 0, 4, and 2, -1. Well, you notice there is probably our solution, and when you draw the line and connect the dots, that is indeed our solution, 2, -1. Thank you very much for watching.